Hello and welcome back to my channel, Java with Ali, and I am Ali. So if you're new to the channel, please check out my previous videos on Java and please like, share and subscribe, and thank you for watching. So today we're going to look at sort comparison and the difference between regular sort and a parallel sort, and this is falling under the topic again of concurrency. So it's going to be a short video today, and then the next video will continue on with concurrency, and then we'll do a summary, and that'll be the end of concurrency. So if you take a look here at sort comparison, we've imported a couple of different packages first. So we have number format, duration, instant, arrays and random. We're very familiar with random and secure random. If you want to check out the secure random video, it's at the very beginning of the beginner series. I think it's video 6 or 7 probably. And the difference between random and secure random. It could even lead to legal consequences, as I mentioned in that video. Anyway, let's get on with it. So public class sort comparison. We have just one class in this particular example, public static void main, the regular main entrance to our program, and we have our new object of random, which I called rand. Then we have two arrays, array 1 and array 2. So array 1, basically all we are doing is getting a random numbers of 100,000 to an array, and then we're just going to copy array 1. We're going to use the clone function or method, as we like to say in Java. In other programming languages you can call them functions as well, and we're going to just copy it to array 2. So both of them now contain the same information. So we have time, so if we were to just say random to the next array 2, the significance of this being it would be different set of random numbers. So cloning it is an exact copy. So you can see here, if I hover over it, it returns a copy of this object. The precise meaning of copy may depend on the class of the object, the general intent of that for any object X expression, and it goes through it here as well. It's really nice to be able to do that in Eclipse, just so you know as well. Time the sorting of array 1 with arrays method sort. So here we have just an arrays method sort. We print out our starting sort as the top of our program. Then we use instant. The instant class is part of the java.time package. And this is just getting the exact time now, as it says here, now. So it obtains the current instant from the system clock. Then we sort the array 1 using our regular sort method, and then we get again the time now from the system clock. Then we display our timing results. So we're using the duration class here from, again, java.time package, where it shows the where you can use the between method sort start and sort end as a comparison. So sort start being the system time that we took here, and the system time that we took here as well from the instant.now. So this is taking our system clock before the sort, after the sort, and then it just converts it to millis, so milliseconds, and then prints it out on the screen as the sort time, their duration sort time. So that would be the first total in milliseconds here, 2002. Time of sorting of array 2 then with arrays method parallel sort, and this is going to be a little bit different because parallel sort brings its benefits. So we have just our display on screen of starting parallel sort, getting again our system clock now, our instant, doing the sort of the clone and then again getting it again, and we're basically doing the exact same again here for parallel sort time. We're getting the duration between the parallel sort, so the time before the sort, sorting it, then the time afterwards, converting it to milliseconds and printing it out on the screen. Then our final part of this program is just to get the percentage. So then we use number format, and which is really up here. We can see the number format is an abstract base class for all number formats, and this class provides the interface for formatting and parsing numbers. So we have our duration here between, and we're going to take our parallel sort start and our parallel sort end for our display, and then here for our percentage we have our number format, our get percentage instance, and we do have to do a casting with this. So we have our get percentage, which returns a percentage format for the current default format locale. Here we have our sort time minus our parallel sort time divided by, again, our parallel sort time, just to see the end as well. So this then sort took a particular amount of percentage. As it's a string, again, it's going to be displayed as percentage s, more time than our parallel sort. So if I look at the output, here it is. Our starting sort is 2002, and our starting parallel sort took 274 milliseconds. So our sort took 631% more time than parallel sort. So you can see parallel sort's pretty nice. Okay, that's it for today. Thank you so much for watching. I will announce also another YouTube channel soon, because I posted a video yesterday on I'm moving. So if you're interested in the vlogs that I'm doing and stuff like that, then check out the other video. I'll announce that later. Happy Sunday, stay safe, and thank you so much for watching. Okay, bye.